Hello everybody, my name is Klaus Theissen and it's today my pleasure to introduce to you the new EVSD 1000 VHF-UHF nav drone analyzer, which is used for extended ground inspection to measure terrestrial navigation signals. ICAO Doc 8071 traditionally describes the standards in ground and flight inspection. In 2018, the document has been expanded by the possibility to use drones for these tests. One of the benefits is the opportunity to use this for measurement applications which are difficult to achieve with traditional ground and flight inspection. Additionally, it can help to make more regular measurement checks and enlarge the interval of the flight inspections to save costs. Other big advantages when using drones for measurements of nav-aid signals are also that runway blocking times are reduced to an absolute minimum, which also saves a lot of money. In the past, some customers have already experimented with drones, and we see here two examples of drones using the EVSF 1000 as a receiver. Due to the weight of the EVSF, which is roughly 3.7 kilograms, quite big drones are necessary to lift the receiver plus antennas and accessories. This results typically in a short flight time and the necessity of lots of external batteries that have to be exchanged between the diverse measurement runs. As there was no standard solution existing, we had the idea to use our receiver and application knowledge to develop a new dedicated drone receiver on basis of the two receivers EVSG and EVSF, which are well accepted in the market. Our mission was to create a drone-optimized receiver with the same or even better performance as the EVSG and EVSF. Furthermore, it should be battery-powered, modular and flexible. And of course, it should provide the accessories you need for field measurements like a VHF-UHF antenna or a data link module. Today, I'm very happy to introduce to you the EVSD 1000 VHF-UHF nav drone analyzer that we launched on the Airspace World in Geneva this year. The EVSD is a small and lightweight box. Its mechanical and electrical design is optimized for the installation on medium-sized drones. It is a signal level and modulation analyzer for drones with measurement modes for ILS, GBAS, VOR, Marker beacon and communication, and comes with an aerodynamic and lightweight plastic housing. The next picture shows how to mount the EVSD on a drone. In our example, we have installed the receiver below a DJI M300 RTK drone and mounted it a little bit in the front in order to keep all drone sensors open for automatic start and landing. Due to this, it is very comfortable to operate the drone and you do not even have to touch the remote control while measuring. The very small and light VHF-UHF antenna EVSD1-Z3, it weighs only 150 grams, is in this configuration mounted on a small mast with a quick release on top of the device. This is advantageous because, like this, the antenna has a certain distance from the body of the drone. This reduces the influence of the magnetic noise from the drone engines and additionally results in a precise dipole diagram. Another option is to mount the antenna below the device. The quick releases that are used for the antenna and the base unit make mounting and dismounting very easy, and there is no need for screwing anything. By this means, the mechanical integration on site is user-friendly and can be done very quickly. As the EVSD is based on the technology of the EVSG, it comes with the possibility to analyze signals like ILS, GBus, VUR, marker beacon and comms. It has the same RF performance as the EVSG and EVSF, a high dynamic range, and delivers up to 100 measurement sets per second. Additionally, it's important to mention that the EVSD 1000 is fully ICAO compliant. This goal is not easy to reach, as some requirements of the ICAO are very tough. The EVSD offers an outstanding input sensitivity due to its very low noise figure and narrowband filters. As a result, the instrument is able to perform highly precise signal analysis even for extreme low levels. It also offers a wide input level range and a steep-edged preselection filter that provide optimized interference rejection for ILS, VUR, marker beacon and comm measurements. As a result, the instrument features high intermodulation suppression and immunity to interference and can deliver reliable measurements even in the immediate vicinity of transmit antennas. This is especially beneficial in the presence of ATC comm signals. Like the EVSG, the EVSD offers real-time measurements and gapless recordings of the measurement results, synchronized with GPS, IQ data recording and streaming, a remote control interface that is identical to EVSG and EVSF, simultaneous analysis of coarse and clearance signal in dual-frequency ILS systems, plus a lot of other options like frequency and time domain analysis. So now let us look at the new and special features of the EVSD. Significant highlights are of course the low weight, under 1.5 kilogram, the aerodynamic shape, the waterproof housing with IP43, the modular concept, plus several interfaces for easy integration into drone systems. Important to mention is the new antenna, especially developed for the EVSD 1000. It is very lightweight and also from size optimized for the use aboard of drones. It is much smaller than a conventional dipole, but has a very nice diagram, as you can see. The transport case offers enough space to store everything in one box. The receiver, the batteries, up to 6 props. By the way, we recommend wooden props to reduce unwanted reflections of the signals. And of course the antenna. So everything you need, except the drone, can be carried in a single case. To make it even more convenient, the transport case is equipped with rolls and can be pulled like a trolley. The EVSD itself offers 2 compartments that can be used for the battery and the Wi-Fi module. The EVSD has only some LEDs for status indication. Nevertheless, the integrated VNC server can also be used to show a virtual screen on PC or laptop. It allows users to remotely access measurement results and change settings without any special software. All that is needed is a PC or laptop with a standard VNC client and network access, in this case best Wi-Fi, to the EVSD. During this presentation, I will not show all available screens of the device, but focus on some important modes. The mode ILS coarse clearance analysis allows you to analyze the 2 carriers of a 2-frequency ILS system, coarse and clearance. So for example, you get a DDM value for the coarse, a DDM value for the clearance, and a DDM value for the sum of the signals. This is very convenient as the measurement can be performed in one shot and it is not necessary to switch off one or the other carrier. All measurement modes offer additionally to the normal view of the modulation values several other views. This is distortion, K2, K3 and THD, identification, dash, dot and gap, and data recorder. This also applies for the VOR analysis. One point I would like to emphasize is that you have the possibility to perform an AM distortion measurement on the DVORs and analyze the 60 Hz and the 1440 Hz components. At the moment, G-bus, as a possible successor of the ILS, is not used in many airports around the globe. To be future-proof, we have a G-bus mode that offers the possibility to fully test G-bus VHF signals, analyze the bursts, perform timing measurements, and take a look at the constellation diagram and the content of the diverse message types. We also have some graphical modes, like for example the spectrum analysis. The scope of the range is from 70 MHz to 410 MHz, which is the band that is interesting for everybody who looks at the nav-8 signals in the field. This can be a big help when analyzing interferers. Additionally, you can perform an AF spectrum analysis. This helps to recognize harmonics or other unwanted signal components. Of course, we did a lot of measurements in our lab and in a climatic chamber to ensure that the EVSD works according to the specifications of the datasheet. However, it is simply not enough for a field instrument, so we additionally performed measurements at airports and collected data under real conditions. Here you see the results of a runway measurement at a local airport using a GPS reference station. The flight was carried out with a drone speed of 10 meters per second and an antenna height of 4 meters above the runway surface. The main measurement value, the difference in depth of modulation, was ICAO filtered, is displayed in light blue and, as can be easily seen, is within ICAO tolerances. Our partner Aerodata carried out further tests at other airports with also very promising results. This brings me to the end of my presentation. As you can see, with our new EVSD, you can measure faster, more accurate, and very convenient. For further information, please visit our webpage. Thanks a lot for your attention.